Bismillahirrahmanirrahim. Assalamu alaikum, dear students. Hope you all fine. Lecture for grade 10. Subject is chemistry, chapter number 12. And today we will do the remaining questions of the exercise of chapter number 12. This is my 21st lecture, and I am your lecturer, Mrs. Saira Jamal. Extended question answers. Question number 3. How can you convert ethene into ethane? How can you convert ethene into ethane? As you can see that in this case, the double bonded carbon containing hydrocarbon is called ene, that is alkene. And which alkene is over here? The two carbon containing alkene is here. So the two carbon containing alkene is called ethene. How can we convert an ethene into ethane or an unsaturated hydrocarbon into saturated hydrocarbon? So for this purpose, in order to convert the unsaturated hydrocarbon into saturated hydrocarbons, I told you this unsaturated hydrocarbon which contain carbon-carbon double bond is alkene, and which type of alkene is here? This is ethene. Ethene which contain carbon-carbon double bond. So now what will happen? Hydrogenation or addition of hydrogen is actually, you can call it hydrogenation, you can call it addition of hydrogen, you can call it reduction process. So you can see that the reduction of ethene will convert it into ethane, and this reduction or this hydrogenation will takes place in the presence of a catalyst that may be nickel and 200 to 300 degrees centigrade. Like at high temperature, this reduction of ethene into ethane will take place. So what will happen? The bond will breaks up, and this hydrogen atom, like there are hydrogen molecule meaning two hydrogen atoms. So one hydrogen atom will add it to carbon number 1, and one hydrogen atom will add it to carbon number 2. So you can see that in this case, the carbon number become hydrogen number become 3. So CH3 like one hydrogen, two hydrogens are already present. After the addition of one more hydrogen atom on each carbon atom will convert it into a saturated hydrocarbon, because the bond between the carbon atoms, the two carbon atom is now a single covalent bond. So single covalent bond is present in saturated hydrocarbon, and which alkane is over here? That is two carbon containing alkane. So this is ethane. Ethene is converted into ethane by hydrogenation of ethene in the presence of nickel catalyst, and at a high temperature, that is 200 to 300 degree centigrade. High temperature is compulsory. At high temperature, this conversion will takes place. The second conversion is conversion of methane into carbon tetrachloride. So conversion of methane into carbon tetrachloride will take place in diffused sunlight. Diffused sunlight is the compulsion or the condition, because if you remember, I told you that conversion of methane at like direct sunlight, the products are different, and in diffuse sunlight, the products are different. So like the first step of conversion of methane into carbon tetrachloride. Tetrachloride means having four chlorine atoms. So when methane react with the chlorine molecule in diffused sunlight, it will convert it into like one of the hydrogen atom of methane will be replaced by the halogen atom. So it will give us the product CH3, because one of the hydrogen of methane will be replaced by the chlorine atom, and now we have three hydrogen left with the replacement of one hydrogen by chlorine atom. This is called methyl chloride, and the hydrogen which is replaced by halogen, that hydrogen will react with the second chlorine atom and will form hydrochloric acid or HCl. This is the first step. In first step, the methane will react with the chlorine atom and will form methyl chloride and hydrochloric acid. Now this methyl chloride which is formed in the first step, it will be reactant in the second step, and you can see will react with second molecule of the chlorine, and one more hydrogen of this methyl will replace by the chlorine atom. So you can see the number of hydrogen will goes on decreasing. From 4 it becomes 3. Now from 3 it becomes 2, and the number of halogen atoms will increase. Here we have one chlorine atom. Now in this case we can see two chlorine atoms, then three chlorine atoms, and then finally four chlorine atoms. And the number of hydrogen will goes on decreasing. You can see four hydrogens, then three hydrogens, then two hydrogen, then one hydrogen atom, and finally no hydrogen atom. So this is actually the steps which are followed for the halogenation of methane into carbon tetrachloride. The third step will be like the this dichloromethane, dichloro, because it has two chlorine atoms. Dichloromethane, it will be reactant in the third step, and third molecule of chlorine will react with it. As I told you, the number of hydrogen atom will goes on decreasing. So from 2 it become 1 hydrogen, and the number of halogen will goes on increasing. From 2 it become 3, and HCl will form in all the steps. Okay, HCl is common in all the steps. The product HCl is common in all the steps, and the reactant chlorine is common in all the steps. Now this trichloromethane, because three chlorine atoms are here, it is also called chloroform, which is used for anesthesia purposes. So trichloromethane will form. This trichloromethane then in the last step will react with the fourth molecule of chlorine in diffused sunlight and will give carbon tetrachloride. You can see CCl4. Tetrachloride means four chlorine atoms and with hydrochloric acid. So these are the steps involved in the conversion of methane into tetrachloromethane. So there are four steps which are involved for the conversion. There are four steps. The reason is four hydrogen atoms are present in methane. So each hydrogen is replaced by a halogen step by step. The final step is until all the hydrogen atoms of the hydrocarbons are replaced by the halogen atom. When all the hydrogen of the hydrocarbons are replaced by halogen, then the reaction will stop. This was all about the conversion of methane into carbon tetrachloride. First step, methane reacts with chlorine to form methyl chloride and hydrochloric acid, then methyl chloride into dichloromethane, then dichloromethane into trichloromethane, trichloromethane into tetrachloromethane. I told you chlorine and HCl are common in all the steps. The third reaction is conversion of ethene into glycol. Ethene into glycol. This reaction is called Bayer's test. I told you this is a Bayer test, which we can use for the identification of unsaturation in a hydrocarbon, and this is also called oxidation of ethene to give a product called ethylene glycol. The product is called ethylene glycol. Ethylene glycol is formed. This ethylene glycol is used as a anti-freezing agent in the automobile engines. So we can use this ethylene glycol as a anti-freezing agent. So you can see that ethene, when react with potassium permanganate, which is a strong oxidizing agent, and that is an alkaline solution, dilute alkaline solution of potassium permanganate, and that's why we are using water as well, because we made a dilute solution of potassium permanganate. It will give ethylene glycol. It is also called dihydroxy ethane, dihydroxyethane, or ethylene glycol. This one OH group is attached with one carbon atom, and second OH is attached with the second carbon atom. This is not N group. And it will also give us manganese dioxide as a side product and potassium hydroxide. Okay, so this is all about conversion of ethene into ethylene glycol. I told you ethylene glycol having the two hydroxyl groups present at each carbon atom. This is ethylene glycol will form. Ethylene glycol will form. Now we have the next conversion, that is ethyl chloride into ethane. How can ethyl chloride be converted into ethane? You can see that the conversion of alkyl halide into ethane takes place in the presence of reducing agents, that is zinc and hydrochloric acid. So if you remember, I told you before that zinc, when react with hydrochloric acid, it will liberate the nascent hydrogen or atomic hydrogen. That atomic hydrogen actually remove the fluorine atom or the halogen from the this alkyl halide. So same will takes place here. There are two halogen atoms, one halogen atom, and there are two hydrogen atoms. So this will take halogen with it and will form the HCl. And what will happen, the another hydrogen, because there are two hydrogen atoms, so another hydrogen atom will replace this halogen. So we will get CH3, which is ethane. This is ethyl chloride. After reduction in the presence of zinc and hydrochloric acid will give us ethane, and hydrochloric acid will form as a side product. Hydrochloric acid will form as a side product. The fifth one is conversion of ethyl bromide into ethene. Ethyl bromide into ethene. You can see we have ethyl bromide, and conversion of ethyl bromide into ethene will takes place in the presence of alcoholic potassium hydroxide. So this alcoholic potassium hydroxide, if you remember, I told you that the potassium, this alcoholic potassium hydroxide, the potassium will take the halogen with it, and if it will take halogen with it, it will form potassium bromide. Potassium, you can see potassium bromide, and this hydroxyl group will take hydrogen from the another carbon atom, not from the same carbon atom from where halogen is eliminated or removed. This hydrogen will take hydrogen from another carbon atom and will form water. And what will these two carbon atoms do? These two carbon atoms will share electron with each other and will form a double covalent bond. So by this way, ethyl bromide will be converted into ethene in the presence of alcoholic potassium hydroxide. Ethyl bromide will be converted into this ethene. Now we have question number 4. Write a chemical reaction to show the preparation of an alkane from an alkene and alkyne. This we already discussed in the preparation of alkanes. There are two important methods for the preparation of alkane. That is, one is from alkyne to alkene and then alkene into alkane. So by this method is called by hydrogenation, because this is, you can see, addition of hydrogen will take place. Hydrogenation actually means addition of hydrogen will take place. So addition of hydrogen will convert first at the alkyne. Which alkyne we have? That is ethine, because it is a 2 carbon containing alkyne. It will react with hydrogen, and this hydrogenation will take place in the presence of finely divided nickel, means powder nickel, at 200 to 300 degrees centigrade and at a high pressure. Then hydrogenation can also be done in presence of other catalysts, like we can also use platinum, we can also use palladium at room temperature. So this alkyne, after hydrogenation, because hydrogenation means one of the bond will breaks up out of these three, and there H2 means there are two hydrogen atoms. One hydrogen atom will add at one carbon atom, and the second will add up at the second carbon atom. As a result, you can see we have CH2, CH2. This is hydrogen in reactant. Mistakenly, it is over here. So you can see we will get, in this case, in reactor side we have one hydrogen atoms, and the product side we have two hydrogen atoms, because addition of hydrogen takes place. So this will be reactant in the second step. Ethine converted into ethene, and then ethene are converted into ethane. The same thing is by the hydrogenation. So by hydrogenation of ethene, which formed in the first step, in the presence of nickel catalyst, and at a high temperature, ethene converted into ethane. This will be ethane having CH3 single bond, not double bond, and this will be CH3. So CH3 single bond CH3, that is ethane. Ethane are converted into ethene, and ethene after hydrogenation is converted into ethane. So CH3 single bond CH3 will form. Now, the next question number 5 is, write a chemical reaction to show the preparation of ethene from dehydration of an alcohol and dehydrohalogenation of alkyl halides. So preparation of ethene by dehydration of alcohol. Dehydration means loss of water, and alcohols dehydrate when their vapors are past overheated alumina. Although I told you that there are some other dehydrating agents as well which can help in the removal of water from alcohols. But in this case we are using alumina. Al2O3 is called aluminium oxide, or also called alumina, at 340 to 450 degrees centigrade. And if you remember, again I told you that hydrogen from one carbon atom and hydroxyl from the second carbon atom will eliminate out in the form of water, and this alumina will help in this elimination, and these two carbon atoms in turn will make a double bond. So that is the method how to convert an alcohol into ethene by this by using the dehydrating agent. By using the dehydrating agent, we remove water from the molecule. Second method, as I told you, is by the dehydrohalogenation of alkyl halide. So you can see we have an alkyl halide over here, and this dehydrohalogenation will take place in the presence of alcoholic potassium hydroxide. And again, if you remember, I told you this potassium will take the bromine. First HBr will form, or hydrobromic acid will form, and then this hydrobromic will react with potassium hydroxide to give potassium bromide and water, and ethene will form. That is the product ethene, which is an alkene. It will form. Question number 6, write a chemical reaction to show the preparation of ethane from dehalogenation of 1,2-dihalide and tetrahalide. So we need two reaction. First one is the reaction of 1,2-dihalide, its conversion into ethane. So you can see we have 1,2-dihalide, two chlorine atoms are present on this hydrocarbon. We can also call it 1,2-dichloroethane. The name, according to IOPAC system, the name of this compound is 1,2-dichlorine atoms are there. So we can call it 1,2-dichloroethane. 1,2-dichloroethane, when react with this alcoholic potassium hydroxide, it will give us the product which will form. That will be, you can see we have only one halogen atom now attached, because if you remember, I told you that the this alcoholic potassium hydroxide, it will eliminate the chlorine atoms from these groups. So potassium from one carbon atom and hydrogen from the second carbon atom will eliminate in the form of potassium chloride and water, and then the two carbon atom will form double bond. So this is, you can call it chloroethene, because only one chlorine is left, but there is double bond, so chloroethene. This chloroethene will be the reactant at the second step, and will react with the second molecule of potassium hydroxide to form, and the reaction will take place in the presence of this alcoholic potassium hydroxide to form, like again, potassium will take halogen with it to form potassium chloride, and hydrogen from the second carbon atom will give water, and the two carbon atoms will make triple bond with each other. So that is the ethane. Ethane in turn, ethane will form. So this is the, by the dehalogenation of dihalide, 1,2-dihalide, 1,2-dihalide will formed in this case. So now this is the reaction which is called dehydrohalogenation of 1,2-dihalide. Second method is for the tetrahalide. Tetrahalide means four carbon atoms. An alkyl halide which is composed of four carbon atoms. You can see 1, 2, 3, 4. Two chlorine atoms are present at the upper side, and two chlorine atoms are present at the lower side. So this is also, we can say that the dehydrohalogenation of tetrahalides will take place in the presence of zinc dust. Zinc dust actually means the powder, zinc in the powder form. It will use to for this purpose. So this zinc will eliminate two chlorine atoms in the first step, and the remaining two chlorine atoms in the second step. So when two chlorine atoms are eliminated by zinc in first step, then the two carbon atom will form double bond and zinc chloride will form. Then this 1,2-dichloroethene will be reactant in the second step, and the zinc dust will eliminate the remaining two chlorine atoms with it and will form ethine. The carbon atom, in order to complete their valency, they will make a triple bond, and second molecule of zinc chloride will form. Question number 7, write chemical reaction showing reaction of potassium permanganate with ethene and ethine. Again, the same thing, that is the Bayer test, but Bayer's test for alkenes and Bayer test in case of the alkynes. So Bayer test in case of alkene, I told you when alkene, for example, ethene react with potassium permanganate, that is dilute solution of potassium permanganate, alkaline potassium permanganate will give us the product ethylene glycol, while the ethine react with the concentrated solution of alkaline potassium permanganate solution, but it will give us the product, the final product is oxalic acid. It will give us oxalic acid, not the ethylene glycol. Ethylene glycol will form in case of the ethene, while oxalic acid will form in case of the ethine. Question number 8 is list some industrial uses of ethene and ethine. Ethene, which is an alkene, has two main industrial uses. Ethene is used to accelerate the ripening of fruits, artificial ripening of fruits, and is most commonly used on bananas and also on citrus fruits. The other use of ethene is the manufacture of plastics such as packing films, wire coatings, and squeeze bottles. All are made up of ethene or alkenes. While ethine, which is also called acetylene, it is used in oxyacetylene flame. That is, I told you, the flame which has very high temperature, and it can be used for welding and cutting of metals. Same like alkenes, alkynes or ethine is also used for artificial ripening of fruit, and like alkene, it is also used for the manufacture of polyvinyl acetate, polyvinyl chloride, polyvinyl ether, and rubber. Like in the manufacture of polymers, and those polymers like plastics and rubbers. Question number 9, explain why IUPAC system is important for naming the compound, or why the system is systematic. Naming is compulsory for chemical compounds. So we know that millions of organic compounds are present in our surrounding, and to understand and to recognize and classify these compounds, systematic naming of these compounds is necessary. Organic chemists began in the last century to devise a system of naming organic compounds that depend on their structure. An international body, that is the International Union of Pure and Applied Chemistry, which is also called IUPAC system, IUPAC system, constantly review the rules for naming organic compounds. So IUPAC system of naming organic compound is based on many principles. Each different organic compound have different name, although we have a different series, and those series help us in naming the organic compound. So for naming medium of organic compound, a system is compulsory to make their learning and their memorization easy. Question number 10 is draw electron dot and cross structure of propane. Prop means 3 carbon containing hydrocarbon, and N means all the carbon-carbon bonds are single bonds. So you can see that these dots are electrons of these 3 carbon atoms, and the crosses are the electrons of hydrogen atoms. So hydrogen and chlorine will make single covalent bond, and you can also see that all the carbon atoms, they are making single covalent bonds. So this is electron dot and cross structure for propane. B is electron dot and cross structure for propene. So propene has at least one carbon-carbon double bond. This carbon-carbon bond is single because only one electron pair is shared between the two carbon atoms. But this bond is double covalent bond because you can see that four electrons, or if we take it in the form of pairs, So two electron pairs are shared between two carbon atoms, and that type of bond where the two electron pairs are shared between the two carbon atoms is called double covalent bond. So as I told you, for alkenes, the presence of at least one double bond is compulsory. So this is you can say an alkene which contains at least one carbon-carbon double bond. And with hydrogen, all the bonds are single covalent bond because only one pair is shared between carbon and each hydrogen atom. The last one is for propine. Propine, you can see in this case, we have 1, 2, 3, 4, 5, 6. 6 electrons are shared between the two carbon atoms, and pairs are 1 pair, 2 pair, and 3 pair. 6 electrons or 3 pairs of electrons are shared between the two carbon atoms. So that type of bond is called triple covalent bond. So for alpine, I told you that the presence of at least one triple bond is compulsory. So as one triple bond is present between the two carbon atoms, so this type of compound is called propine. The rest of the bonds are single. You can see only one electron pair is shared between these two carbon atoms, and one electron pairs are shared between carbon and hydrogen. So you have to take the electrons of carbon in this case in the form of crosses, and those of hydrogen as dots. So this is not compulsory. You can take electrons of carbon in dots and that of hydrogen in cross. Okay, that is not compulsory. So these are all the 10 question answers of the exercise. The think tank is left. Inshallah, we will do the think tank in our next lecture. Till then, take care. Allah.